Hello, dear students. Welcome to massive open online course English for Mining Engineering, Module 1, Rocks of the Earth's Crust and Useful Minerals. Last time we studied weathering. Today we study Unit 4, Metamorphic Rocks. Unit 4 covers information about 4.1 What is metamorphism? Types of metamorphism. 4.2 Agents of metamorphism. 4.3 Metamorphic rocks and the types. 4.4 Common examples of metamorphic rocks. The course was created by senior teacher of Foreign Languages Department, Master of Economic Sciences, Yarema Tatiana Vladimirovna. Okay, let's start. What is metamorphism? Metamorphism is a transformation of existing rocks to rock with a different mineral composition or texture. Metamorphism takes place at temperatures in excess of 150 degrees Celsius, and often also at elevated pressure or in the presence of chemically active fluids, but the rock remains mostly solid during the transformation. There are various forms of metamorphism: regional, contact, hydrothermal, shock, and dynamic. Let's continue. Types of metamorphism. Regional metamorphism. Regional metamorphism occurs when rocks are brought to great depths relative to where they originated. The extent of regional metamorphism is completely dependent on the depths, since temperature and pressure increase with depths. Number 2. Contact metamorphism. This type of metamorphism occurs when rocks are overtaken by magma that rises from deeper regions to the surface. That's why it is called contact. Fission metamorphism. A third type of metamorphism occurs at surface rocks that are compressed when the movement of the Earth's crust pushes them toward each other. The degree of metamorphism depends on the intensity of the pressure. 4.2 Agents of metamorphism. Metamorphism is a process of formation of metamorphic rocks from sedimentary and igneous rocks. During this process, different agents are involved. These agents are called agents of metamorphism or metamorphic agents. Following are the different agents of metamorphism. First, heat. Heat is the most important metamorphic agent because it provides the energy to drive chemical reactions that result in the recrystallization of existing materials and or the formation of new materials. Here's how heat causes metamorphism. Thermal energy results recrystallization and dehydration. Thermal energy breaks chemical bonds. The increased rate of reaction. Heat leads to changes in mineralogical composition and crystals, and that leads to make coarse texture. Earth's internal heat comes mainly from radioactive decay within the Earth's interior and from converging plates. Pressure. There are two types of pressure acting during the formation of metamorphic rocks: uniform pressure and direct pressure. They are also known as equidimensional pressure and directed pressure. Uniform pressure leads to a change of volume of rock by pore space reduction due to closer atomic packing, while direct pressure leads to the changes in shape, texture, and structure. Chemically active fluids. The change in rocks due to the chemically active fluids take place through a partial or complete solution of the minerals. The most chemically reactive fluids derived from magma and other sources are water, carbon dioxide, and etc. They lead to the chemical changes in rocks. 4.3 Metamorphic rocks. Metamorphic rocks have been developed from early igneous and sedimentary rocks by heat and pressure at some depths and very often in the great mountain zones. The changes are in texture, in mineral composition, and in structural features of rocks. Two general kinds of metamorphic effect are recognized. 1. Dynamic metamorphism, resulting from strong compression and some increase in temperature, and thermal metamorphism, caused by high temperature in rocks. Extreme metamorphism in the some mountain zones has resulted from combined dynamic and thermal effects. Where are they found? Most metamorphic rocks are found in mountain ranges where higher pressure squeezes the rock together. They pile up from ranges such as Himalayas, Alps, and the Rocky Mountains. Metamorphic rocks form deep and core of these mountain ranges. The ribbon-like layers are common property of all metamorphic rocks. Metamorphic rocks and their types. So we can see that there are two types of metamorphic rocks. Foliated sedimentary rocks. Foliated rocks are rocks that possess a lowered appearance. They are formed through extreme pressure in conjugation with the heat, which helps elongated minerals attain a foliated pattern, known as foliation. This plating process creates thin layers and directional patterns in the rocks. For example, gneisses, phyllite, sheets, and slate. The second type, non-foliated sedimentary rocks. Non-foliated sedimentary rocks form much in the same way as foliated rocks under high pressure and extreme heat conditions. The only difference is that non-foliated rocks occur when minerals are irregular or non-elongated. Under high pressure, the minerals compress, however, they do not align into sheets or platy layers. Examples of non-foliated rocks are hornfels, marble, novaculite, quartzite, and skarn. 4.4 Metamorphic rocks examples. Some common examples of metamorphic rocks are listed and described below along with the names. Marble, a non-foliated metamorphic rock produced from the metamorphism of limestone or dolostone. Anthracite, a non-foliated metamorphic rock made from pine debris due to the exposure to high heat and pressure. Most of the oxygen and hydrogen from anthracite have been driven off. Gneisses, a foliated metamorphic rock, has a banded appearance and is made up of coarse mineral grains. It contains abundant quartz or feldspar minerals. Gneisses is produced by medium to high-grade metamorphism. Hornfels, a fine-grained non-foliated metamorphic rock with no specific composition. The process of contact metamorphism produces it. Mariposite, a metamorphic rock that contains green mica minerals, imparting a green color. The green mica usually accounts for a small percentage of the rock. The significant percentage consists of the quartz, calcite, dolomite, ankerite, or barite. Novaculite, a dense, hard, fine-grained, siliceous, non-foliated metamorphic rock developed from sediments deposited in marine environments where organisms such as diatoms are presented. Phyllites are fine-grained rocks formed under the low to medium metamorphic conditions. The parent rock is slate. Phyllites are very subject to mechanical disintegration and have a glossy sheen that distinguishes them from slate. Amphibolite are foliated, high crystalline rock composed mainly of amphibolite and plagioscale. The parent rock is typically basalt. So that's all for today. The next time we are going to study grammar, the active voice and the passive voice. Thank you very much for your attention. See you next time. All the best.